Hello everyone. Am I audible?
Yes, sir, you are audible.
Yes, sir.
Okay. Is my screen visible?
Yes, sir.
Yes, sir.
Okay. So in the yesterday session, we have completed till like areas how you reshape it, okay, and the broadcasting part, and how you do some of the operations along row wise or column wise, and the filtering part. So till this some mean variance norm, we have completed it, right? So before moving ahead, anybody has any doubt? Okay. So I shared the collapse that we are going to discuss in the chat section. Okay, you can open the NumPy erase collapse. So today we will be starting from the stacking. Okay, so what is stacking means? Yes, only the collapse that are there in the folder. Okay, we will be covering only those, and after that only like perceptron and the SVM part is remaining. That will be covered in the tomorrow session. Okay, so we have this a matrix A and matrix B. So there are two types of way in which you can stack them. One is like top to bottom or vertically or horizontally. That is like this, that is given to you. At first, only the A matrix part is there, and below that, just below that, the B matrix part is there. So this is like top to bottom or vertical stacking. And another is left to right or column wise stacking, which is this. That this is your A matrix part, and on the left to that, oh sorry, right to that is B matrix part. So this is left to right stacking. So there are multiple ways in which you can stack them. So let's start first with importing libraries. Then we will create the matrix A using arrange function here, okay, from 1 to 5, and I will reshape it into a 2 cross 2 matrix. And for B, we'll go from 5 to 9 with reshaping it to 2 cross 2. Okay. So let's look at the matrix A. This is your matrix A, and this is your matrix B. Now, first way to tag them is using the concat method. Okay, so if you type np.concat, and there would be two methods that it will show in the suggestion. One is concat and another is concatenate. Okay, concat is just like the shortcut keyword for the concatenate. Okay, so both works the same way. So I will be using the concat. In the concat, you have to pass the list or in the form of tuple, the arrays on which you want to do the stacking. So as here as in the documentation it is shown, okay, where A1, A2 are the arrays or the matrices on which you want to perform the stacking or concatenation. Okay, so as we want to do them on A and B, so we will type them A and B. Next is axis. Okay, so now tell me if I want to do it on like top to bottom, then what will be the value of axis here?
1.
0.
It will be 0. Only then it will be top to bottom. One is for left to right operation. Okay, so this is one way in which you can do the stacking. There's one more, np.vstack. Okay, so this is vstack here means vertical stacking. So here you don't have to provide the axis, it will automatically do the vertical stacking. Okay, that is like top to bottom again. Okay, and there's one more, uh, however it is depreciated now, that is row stacking. Here also you don't have to provide any kind of axis. Okay, but row stack is now depreciated. Instead we can, it also says use np.vstack directly. Okay, but yeah, these are like three ways in which you can do the top to bottom or vertical stacking. Concat, another name for this is concatenate, vstacking, and row stack. Okay, in these two you don't have to pass the axis, but with concat you have to pass the axis. Okay, any doubt so far?
Why 0 here, sir? Axis.
because we want to do vertical stacking or top to bottom, like first this and then below that this. Okay, so for top to bottom operation we do x is equal to 0, or left to right we do x is
Zero axis is for rows, right?
yeah, rows also you can say. So because we want in the next row, so in that way also you can. Okay, any more doubt?
No.
Okay, now we will just do the left to right stacking now. So again the similar method. First is np.concat. Okay, now instead of passing x is equal to 0 we will pass x is equal to 1. So this will do the left to right stacking. Now before we saw the v stack, similarly we have h stack for horizontal stacking. It is already pinned in the chat. The first pin I will again send it though. Yeah, so another for the horizontal stacking, h stack is this. Okay, so this is will also stack them left to right. And then there's one more column stack. Okay, so column wise we want to stack them. So these are the three methods again from which you can stack two matrices. Anybody has any doubt? Okay, so now we will look at some miscellaneous function like max and argmax, min, argmin, sort and argsort. Okay, so let's create an array of let's say 10, -3, 2, 15, 5. Okay, now first we will perform the max and argmax. So np dot max of x will give you the maximum element from the x array. Okay, while if you do np dot argmax, okay, this will return the indices of the maximum element. Okay, max returns the maximum element, argmax return the indices or index position of the maximum element in the array. Similar works for the min also, that np dot min will return the minimum element, while np dot argmin of x will return the indices of the minimum element. Okay, now there's one more sort. So np dot sort of x will return the sorted array. Okay, so your x was this, and the sorted version of this is given by using np.sort. Okay, and np.argsort will return the indices in which the array would be sorted. Okay, so as -3 will come in the first position in the sorted array. Okay, so which is at the index position of 1. So at the index of that we have 1 in the argsort. Okay, then comes the 2 which is at the second index position, so that's why it is 2, and so on. Okay, yeah.
Sorry, sir, could you please repeat that arc sort and
Yeah. So the sort function will return the array in the sorted form, -3, 2, 5, 10, 15. The argsort will give you the indices in the like in the original array. Okay, 1 minute. Yeah. So in the original array, -3 is at the position of 1 index. Okay, which should come in the first position in the sorted array, right? So that's why here it is 1, which is the index of the element in the sorted array. Okay, from the original array. So 2 here is at the index 2, which will come here. Okay, so basically it will return the indices, okay, based on the original array from the sorted array. So from the sorted array, here we have -3, which was at the index of 1, so that's why we have 1. 2, which was at the index of 2, that's why we have 2. 5 was at the index of 4, So that's why we have 4. 10 was at 0, so 0. And 15 at 3, so 3. Clear?
Can you go a little bit up, sir?
Yeah, sure.
Min, max, argmin, argmax. Little bit more.
Uh,
Okay. Okay, sir.
okay.
Sir, if suppose we have two maximum numbers, the
Hmm.
arg will return what?
Okay, two
Two num
same num.
two yeah, two same
Okay,
numbers.
let's try it out. So now we take one more 15. So max will return the 15 only. R max will return 3. Okay, the first encounter it will return. Then.
Okay, sir.
So it's not that these function only work on the single dimensional array. You can work them on the two dimensional array also. Okay. Okay. So this is your mat. Dot array. Oh,
3 times array.
3 times. Okay. So let's do np.max and from x. Okay. Now here you can pass the axis. So if I do x is equal to 1, okay. Tell me what it will return for this output. What will be the output for this code?
5.
5,3.
5.
5, 3, because it will do sorting both ways. So in the left to right operation, from first row, there's maximum is 5. Then from the below one, it is 3. Okay. If we do x is equal to 0, then
3,
3, 3, 5.
5. 3, 3, 5.
correct. Okay. If I do not provide the axis, then it will just return the overall max. Okay. Now for the sort, let's do x is equal to 1. Okay. So the first row was already sorted here, 1, 3, 5. From the below one, it has sorted -4, -1, and 3. If I do x is equal to 0, then it will sort based on this. So these position changed for -1 and 3. And here also -4 it become first and 5. If I do not provide the access here, then it will sort in both manner. Okay. First here and second here, -4, -1, and 3. So any doubt?
So it is sorting in the 0, 1 axis, right, sir? No, 0 axis.
0. Not 0, 1.
No, if you give only sort, then it is sorting in.
See, this is same as the output of 1. Okay.
Okay.
So left to right sorting it is doing. Okay. So for now I will keep it x is equal to 1. Any doubt? Now comparing two arrays. Okay. So let's say if you have two array, okay, and y equal to np dot array. So we know that these two arrays are the same. Okay. But if you just write x equal to y, okay, this will return the Boolean array. And for general if condition statement, if you want to use that if x is equal to y, in that place you cannot use this. Okay. So NumPy provides something called as array equal. Okay. X comma y. So this will return true if both the arrays are equal. That means element wise they are equal. If they are not equal, if any one of the element is not equal, then it will provide false. Okay. Now
So
one
in
more
the
thing.
first one, what will it return, sir? X equal to y, the same thing.
This Boolean array. This
So
is what it will
false, true, true, false, true, true, sir.
yes, false, true, true. Okay. Now sometimes what might happen that the elements are not exactly equal, but using some tolerance, you can say that they are equal. Okay. So for that purpose, you can use np.all_close. Okay. Now there's something that we have in this documentation that how the tolerances works. Okay. So it has some parameters, atol and rtol. Atol refers to absolute tolerance and rtol refers to the relative tolerance. Okay. And if the following equation is element-wise true, then all close will return true. If this equation comes out to be true for two vectors A and B, for each element in the vector. Okay, element-wise. If not, even for any element-wise operation, this equation is not satisfied, then this will return false. Okay. So now if I showcase the first, I have to create two variables and y. Now here, let's take 1.0001, 0.0001, 0.0001. Okay, and this is ysm. So you can use np.all_close. Okay, x and y. So the relative tolerance we can keep here 0, and the absolute tolerance we'll keep 1 power minus 2. Okay, 10 power minus 2. So because our tolerance will become 0, so this part itself will just vanishes, and it will just check whether the absolute difference between the element wise, okay, is less than equal to the absolute tolerance value. Okay. Okay. So this will return
What
true
is
here.
relative tolerance?
Relative tolerance is just the parameter that they use. Now we have to check the notes in what exactly how they are measuring it. It's just something that they use, but they have not mentioned what does RTOL actually does.
Does it
We used to keep it
round
as
off?
0.
We are keeping it 0 so that this part will vanishes, how it is dependent on the second
Okay.
element. Okay. And so
Okay.
that just the absolute difference would be within this absolute tolerance value. So we don't
Okay.
want any relative tolerance with the second element. Okay. While comparison, we just want the absolute tolerance here. That's
Sir, does it round off and compare the things?
not rounding off. If you look at the how its equation is checking. So 1.0001 minus 1. Okay. This will return 0.001. Okay. And it is checking whether this is less than equal to this quantity or not. Okay.
Okay.
So at all, that is this.
1
This
e
at
to
all.
e minus 2 is what? 10 to the power
10
minus
power.
2.
Yes, 10 power minus 2. Okay. So if it is less than equal to, then it will return true. Otherwise, it will return false. Clear?
Sir, just can you go back to that sort? Using sort, just using sort. Last, sir.
Hmm. Yes.
What it is doing if you don't give the access, sir?
This will sorting in based on the x is equal to 1. Oh, sorry. Uh, I got 10. Okay.
Okay,
So left to right,
okay,
it is sorting.
okay, sir.
So anybody has any doubt till now?
Yeah, in that sorting, if axis is 1, what exactly is the difference?
I guess by default it is taking 1. So
Okay,
if you provide x is equal to 1, then this is what you will get. If you provide
okay,
x is equal to 0, then it will sort top to bottom. Okay. So
top to bottom. Okay,
it will compare between 1 and 3 here,
okay,
then this 3 and minus 1, and 5 and minus 4. Okay.
Yeah.
Any more doubt?
Sir, can you explain arc sort with
Okay.
x equal to 0 and 1?
With x equal to
Sir, x is equal to 0 and 1.
arg sort. Okay, so arg sort here we were using no access. If you want to use here
Mm-hmm.
arg sort with x is equal to 1. Okay, so it will just return the indices. Okay, based on the again x is equal to 1. So think of it like only one dimensional array first, 135 how
Mm-hmm.
it will do, and based on that it will return. Okay.
Okay. Okay.
Any more doubt? Okay. So the final thing in the NumPy remaining is how you handle the images. So we will be doing this for the PCA. Okay, while training the PC on MNIST dataset. So for that we have to import the Keras MNIST dataset from Keras library. And also matplotlib. And to import MNIST, we will be using Keras dataset. However, there are different ways also, like from scikit-learn also you can import Keras, but we'll be using from scikit-learn also you can import MNIST, but for this we will be using Keras dataset. So MNIST dot load underscore data. Okay, this will load the data set, MNIST data set, but this will load in the form of a tuple, and the tuple would be like train comma test. Okay, so that's why we will write it as train comma test. Okay, and in the training also we have the tuple of x comma y. Okay, and in the test also we have it in the same format, x comma y. Okay, so if we check the shape of metric x, it is a three-dimensional array, 60,000 comma 28 comma 28. So there are 60,000 data point, okay, or 60,000 images, and one image is of shape 28 cross 28 grid. Okay, now if you want to plot the image, so let's look at the two case. Okay, so what we are doing here, y is equal to 2. Okay, so that means where the label is 2. Okay, I am extracting those data points only, and in that I am only extracting the first element. Okay, so we will plot this image. plt.imshow is the method using which you can plot the image. So this is how it will look. There's something called a CMap equal to gray. So it will give it this. It will give it as a grayscale image. Okay. And the way we can do this is how you can reshape this. Okay. So
So that x data x is what? X is a three-dimensional array, right?
yes,
And we are extracting which image out of that. This is a 28 cross 28 picture, right? Whatever you
yes.
have. So we are taking the first picture of that first zero.
See what we are doing here. X of y equal to 2. So y corresponds to the label, and the
O-
label is values like 0, 1, 2, 3, which number image is this. Okay.
Okay.
So wherever the label is 2, it will extract those images only first. And in that, we are only taking the first image.
For label equal to 2 also there will be a three-dimensional x, right?
No. It will be just two-dimensional, 28 cross 28.
Okay.
Okay. So if I show like the output of this, how this will look, just part. Okay, show data. Then this is how it will look. Okay, it's a 28 cross 28 grid image, which has data.
Can you please be a bit slower because I
Yeah.
was not able to follow.
So first we load the
Yeah.
data set till this part was clear.
Yes.
Okay. After loading the data set, okay, what we are doing is plotting the image. Okay. So for the plotting purpose, we are going with the two.
The next step is load. How do we load this?
Mnist dot load underscore data. Okay.
So what is the train and test over there?
The training set and the test set. Okay. The mnist dot load underscore data returns the data set into form of tuples, the training set and the test set. Okay.
We will be using the train.
Yes,
Train
we'll
set
be using
one.
the train. Yes. And in the training set also, we have in the form of data as a tuple x comma y. So data matrix comma label vector. Same is there for the test set also. Okay.
So what is y? Can you give the shape of y? What is y?
There's a label.
That's the label vector. It is of shape 60,000 comma. Okay.
Okay.
And if I like show the unique values in the y, you can show them using np.unique of y. So this will give us the unique values in the y. Okay, so there are these 10 unique labels 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay.
Okay.
And there's something called as unique counts. Okay, which will return two things. One is the unique values, other is their corresponding counts, how many times they have occurred. So that means 0 has occurred 5,923 times, 1 has occurred 6,742 times, like that. Okay. And basically using 0, you can extract the unique values, and using 1 in this, you can extract their counts. Okay.
Okay.
Sir, here we are slicing with respect to y equals to 2, right? Okay.
So we are only extracting
That,
those images which label is 2.
right, but this uh, x has certain rows and columns. So here, uh, does x have the information on y? Like,
See,
I'm not
this is
able.
how this was covered in the yesterday session, like the advanced indexing part. That
Okay, if
x
we
of
can see.
see y equal to 2 will return an array of true false array. Okay, it will return an boolean array,
Okay,
and
okay,
that
yeah, got it. Yes,
uh,
sir.
okay.
Thank you. Okay.
So we are checking for the 2. You can check for any other number also, like let's say 7. So that's how the 7 will look. Okay.
So x y
If
equal
the
to
value
7 will have those many number of, for example, if you go up, uh,
Yes.
so 2 is having 5958 uh,
Yes.
number of. So the first one out of that is shown here.
Yes. Now this is for 7. So for 7, it would be 987. So 7 has
6265.
6265 numbers,
Out
out
of
of which
this,
one?
the first one.
Yes, the first one is shown here.
Okay, okay.
so we can change the number like 0 to anything, 100 or something.
You mean 0 here?
Yeah.
Yes, you can change it to anything like 100. This one. This might be looking same. 70. Yes. Okay. 90. Okay.
If
CMAP
suppose
equal to
you are
grade.
giving it as
What is
7,000, what will happen? There is no data for that. So
Sorry, one by one.
7,000 if you give, say it
Okay,
is having only
7,000.
6. Yeah.
Yeah. So this should throw error. Yes, index is out of bound. It is
Okay.
of shape. Okay.
6264 only it will give maximum. 6264.
So this is the image that you will get. Okay. Any more doubt?
CMAP equal to grade?
Yeah, see, ma'am. So see, this will give us a grayscale image. If you do not pass it, then it will be like RGB color image like this. Okay. So for the
What's
grayscale image,
happening is what's happening as the index value is increasing?
it's just different images. Okay.
No, but
That's
there
not,
is no pattern, is it?
See, those are like different images, right? The goal for the MNIST data set is looking at the test image, you have to predict what type of image that is. So these are just the data, the different ways you can write the 7 using N. Okay. So using those data, when you feed it into the model will learn something, and using that it will predict whether the given image is of what number. Okay. So you can
These images are all from a population, a collection of populations. It.
yes. So how
And so many sevens are repeated, is it?
not they are not repeated. They look like repeated, but there is some changes. See, like this 7, if you see. Now let's say this 7, this is completely different. Right? Now this one dash also. Okay. So some variations would be there. How a
So
different
I
person
think
write.
it is the number, the number of ways that different people will write 7, right?
Yes.
It is giving that key how different people will write 7.
Yeah. See, maybe we can see more variation in the 4 because 4 will get some people like 4 like this. Okay. Some will write it like this here. This 4. Okay.
Okay. So you mean to say that when it will capture 7 or 4, whatever it is, in any form, whatever people are writing, is it?
Yes. This is the data set of those handwritten digits image.
Okay.
Okay.
So where did you get this data actually? I think I could see there is a link you're right.
Yeah, this is we are loading from the KRS.
KRS data sets. Okay. So is it a kind of central location where these kind of data are available?
This is basically like, yeah, it's the DL library which has many other data set also. Okay. From there we are importing this data set in the collab.
Okay.
So the final thing comes here was the reshaping of this data metric X, which is currently of 3 dimension to a 2-dimensional matrix. Okay. So remember, yesterday I told one thing that if you pass one element from here, 60,000, right? 1, 2, 3, 4, okay, and put -1, okay, then NumPy will automatically figure out what should be the appropriate size of that, and based on that, it will reshape.
Sir, what is X here? -1 will correspond to 28 into 28, right?
Yes, 784.
Sir, what is X here?
X is the data matrix that we have captured here, right?
Okay. Already we have assigned.
Okay, so you can reshape it into 60,000, -1. So now we have number of data points to be 60,000 and the features are 784. Okay. Yes.
What is the code just above in the cell 72?
72. This. Okay.
Equal
So
to
instead of
2,
passing
0.
this into this show, I'm showing the output of how it will look.
Okay, thank you.
Sir, initially it was a 3-dimensional data set, right?
Yes, it was a 3-dimension on which we did the reshaping to make it a 2-dimensional data.
So automatically it can be calculated.
Yes, the number of features it is calculating automatically.
Can be reshaped to 1 dimension also, to vector also.
Yes, you can reshape it to 1 dimension if you want. So for that, I think this will throw error. Oh, this will. Okay, so it has combined everything. So it's there's a size 60,000 times.
Multiplied everything.
And this is of no use for us. This is what it is useful. Okay. So, any more doubt, anyone?
Sir, how it is happening in background?
The reshaping we did discussed it yesterday, right? So just how that it is working. So see, this
That
is a
is
28
fine.
cross. See what it will go. Okay. Now here it is a 28 cross 28, right? So one row. Okay. Then another row like that. What it will do, it will basically flatten this array. Okay. So after this 0, instead of this bracket, it will again start from the row like that. Okay.
Fine.
Any more doubt?
No, sir, we can proceed.
No? Okay, so we will basically go to PCA. Okay. So
For every number, it will be having a 28 cross 28 matrix wherein the ith and ith row and jth column will contain a value if it is true, something like that.
where?
Because I see some 135, 252 in this. Yeah.
See, these are basically
Because I see
are
most of the things are zero.
these are
Somewhere
basically
it
the
is
values
having.
between 0 to 255 values. So that is for like
Color codes.
Yeah, color codes. Okay. So most places are 0. That's why it's like black most of the
All are
places.
black. All the blacks are zero, and then
Yes.
where
So
there
wherever,
is white or gray or things
yeah.
like that.
So that's how it is forming the image.
Okay, we have some numbers. Okay. Thank you.
So let's switch to PCA now.
So, sir, where there is zero, there is no image.
No, there's image. It's just a
Blank.
black color. Okay. Okay. So let's again import the libraries. So first thing we will do is we will start with a toy dataset example for performing PCA. And for that, we will create a dataset, okay, using multivariate normal. Okay. So for that, we will do np.random.default_rng and set the seed value to be let's say 42. Okay. Then let's set the mu to be 5 and covariance to be 9,1. Okay. So we will create this now. rng.multivariate normal will pass this mu and covariance matrix, and then the size of the data set. So let's start with 100 data set. Okay. So if you just do this and check the shape of X, this could be 100 cross 2. But we want in the form of D cross N, so we'll go with 2 cross 100. Okay. So this is same as what we did yesterday also while doing the sampling. Now we will visualize this, how it will look. So plt.scatter 0 x1. So this is how your data set will look. Let's, yes, any doubt? And color is black. We'll also draw one vertical line and to make the scale similar. So this is how your data set will look. Okay. So in PCA, what will be the first step while performing it?
Center the data.
Correct. So first task is to center the data set. And for that, we will do x minus equal x dot mean. What should be the axis value here?
Is equal to 1.
Correct. Will this work?
Will this work?
Sir?
Excuse me, sir.
Yes.
Sir, once can you scroll up? I was like doing by yourself. So, what is the covariance you have taken in this example?
Just covariance.
Okay.
One.
Thank you, sir.
Can you
Yes.
just go a little bit up for to visualize that code? I didn't go. I didn't do it well.
So we are plotting the scatter plot. Then just for the x-axis and y-axis line, we are doing this. And this is for the same.
So we have taken n cross d or d cross n?
D cross n, 2, 100. Okay.
This axis equal to equal means what? What does it mean?
This will basically light on the like similar scale. Okay. So for the x-axis and y-axis, it will bring them on the similar scale. Not exactly same, but similar.
Okay, you mean the range.
Yes, the range of the axis and y.
Okay.
Now here.
But here it is not equal, sir.
They are. I'm not saying they will be equal. I'm saying it will bring them on the similar scale. So here the range is like from 0 to 7. So here it is like from -2, 3 to 7 something. Okay. So on the similar scaling, it will bring, not exactly equal. Okay.
You mean to say the upper limit is nearly same, but the lower limit is different.
No, actually, the distance looks like it's same. 0 to 2 is twice 0 to 1 on the y-axis.
Scale of the
Scale
axis.
is, yeah, are equal.
Okay.
Yeah,
So
that's another point.
coming back to this center part, will this code work or it will throw any error?
Should be x is equal to 0.
Shape.
No, x is equal to 0. This x is equal to 1 is correct. We have to do the reshape.
Reshaping.
Reshape it to
0.
Yeah, it will be x dot shape
Uh,
of 0.
2, 2, 1, 2, 1.
X dot shape of 0.
D 1, D comma 2 comma 1.
yes, correct. D comma 1 or 2 comma 1?
2 comma 1.
So I will do this. Okay. Here I will put D comma 1. Okay. So I hope this part is. Oh, I did not. Okay. Same thing we did yesterday also. Okay. I hope it is clear. Now next step is to compute the covariance matrix. So P is
X by n.
Correct. Next is basically principal component. Okay. So eigenvectors of the covariance matrix. So you can get them using np.cleanedge dot.
So before getting into the details, the principal component we use it for dimensionality reduction set.
Yes.
How does it happen?
Okay. So see, if we look at here in a two-dimensional case, okay. So what it will do is basically like kind of rotating the axis. Okay. Now, how the reduction is happening, dimensionality reduction, that I will show while performing the PC on the MNIST data set. Okay. For this one, it will like kind of just rotate the axis if you take both the PC. If you take one PC only, then it will just give you one line along which you will get the maximum variance. So line is like one dimension. Okay. So from 2 dimension, we'll go to 1 dimension. Okay. Yes, Shri Ganesh. Oh.
So can we use this np.cov for measuring this covariance matrix?
np.cov. Schematic covariance matrix given data in weights. You can just look at the parameters and how it will work. Okay. And based on that, if you are able to figure it out, this is also fine. I think it should give you the same result. Okay. So to find the eigenvectors and eigenvalue, okay, you have to use this linear module, which contains the linear algebra function, in which you will use I. So H here is for like Hessian matrix. Okay. So in which you will pass your covariance matrix. The output for this is also in the form of tuple. The first part is eigenvalue and the second part is eigenvector. Okay. And they are arranged in the form of like ascending order. So that means eigenvalues are like the smallest eigenvalues are in the starting, and in the end it is like largest eigenvalues. And based on according to eigenvalues only, your eigenvectors are arranged in the ascending order. Okay. So that means the first PC, if you want to extract, that will be like from the
last one.
at
Last
the
one.
end. Yes. Okay. So let's try to visualize the original data set and the center data set, okay, with the obtained PC. Okay. So plt.scatter x0 and x1. This will plot the scatter plot. Now we want to plot the PC also. Okay. So to plot the PC, so maybe
X is now the centered matrix, right? X is
yes,
not the original matrix now.
yes. X is now the centered matrix. Okay. So now whatever you will be seeing is will be the center data set. Okay. Okay. So tell me if I like have my PCS here. Okay. So I have my PC here in the form of like W1 and W2. Okay. Now, if I want to plot the line passing through this PC or this eigenvector W1 and W2 from origin, then what would be the slope of that line?
y2 minus y1 divided by x2 minus x1.
Yeah. So see, W1 here corresponds to like two W1 here is like W11 and W12. Okay. So because it will be a two-dimensional vector, right? Now, if I want to draw a line which passes through this vector from the origin, then what will be the slope of that line?
W12 by W11.
Correct. Okay. So that's what I hope there's anybody has any doubt how it will be W12 divided by W11?
No, sir.
Okay. So just that's what I wanted to convey. So for that, first I will start with this length space. Okay. -2, 2. Now for the first PC, this is my first piece. Oh no. I back -1. Okay. So if you look at IGVAC only, okay, this is your first PC here, -0.73, -0.68. And the second PC is 0.68, -0.71, because they are arranged ascending order, right? And if you do this slicing, this will return the first PC. Okay. So this is your first PC and your second PC is this way. Now, as we want to plot the line, so we'll do this y1. W1. So W1 will have two elements. So 1 divided by W1 of 0 multiplied with this X. Okay. And same for Y2. W2 of 1 divided by W2 of 0 multiplied with X. Okay. Because W is here like again two-dimensional vector. Okay. The first element means we are extracting the Y-axis element and then X-axis. Right? Okay. Next is just plt.plot X comma Y1. Let's give it color. So purple. And also
We have 50 points, right? Because we have not chosen the third. So we have 50 points in this lead space.
yes, correct. So this is your W1. Same thing here. So this would be Y2, W2. Okay. PLT dot. So these things I will just copy paste from here. And the legend. As we have given the label, so we can plot using legend. So this is how it will look. Oh, sorry, both are purple. Not the purple, red. So this is how the final output will look. Okay. Purple will be your first PC, red will be your second PC. This is your center data set scatter plot. Okay. And this was the code. Anybody has any doubt here?
So this eigenvec, how you have done? I mean, the first column represents
rows.
Rows, right?
So we have
So
taken out the rows.
both the rows.
And
And
we are
out
extracting
of
the
that,
last column. We are extracting the last column, right? -1.
okay, so both the last column of both the rows we have selected.
Yes, correct. So that will basically this vector, right?
Right. Okay.
So each row is a feature row, correct? For all the data points. So there are two features, so we have two rows, right? X0 and X1.
Yes, this is again like all your eigenvectors are arranged column wise here also. So this is your first eigenvector.
Each column is a feature or each row is a feature?
Yeah, sorry, each row will be a feature. Correct, my bad. Okay. So here
Not
also like your, yeah, not in column. Because here also our vectors are arranged column wise. So this is your eigenvector. The column is your eigenvector.
So the first so the eigenvector is not the row; it is the first
column.
Okay. And the second one is the first that is the highest the first eigenvector, and this is the second eigenvector.
Yeah, because they are arranged ascending order. Okay, eigenvalue that we have got here, these are arranged in the ascending order, and according to that only your eigenvectors are arranged. Okay. That's why this is your first PC, this is your second PC.
Okay.
So can you please repeat that y part, y1 and y2? How
This
did
one.
we calculate? Yes.
So see, you have this vector W1, okay, W1, W2. Now, if you want to draw a line which is passing through from this vector, okay, and passing through the origin, so how you calculate the slope basically, like y2 minus y1 by x2 minus x1, right? Now, you want to have a line which passes through this vector and also from the origin, right? So from the origin, the coordinates are 0, 0. From the vector, the coordinates are this. Okay. So if you just simply put them here, you will get W this W12 minus 0 divided by W11 minus 0. So basically the W12 divided by W1. And the equation of line is y equal to mx. So slope multiply times the x.
Okay.
And that's what we did here.
Sir, which editor it is in which you are writing?
Huh? Sorry.
The editor on which you are writing.
Mathscha.
Math jar.
Mathscha.
Mathscha.
Yeah. Mathscha.io.
Okay.
Okay. So, anybody has any doubt till now?
So in the OPP, we need to draw all these things and show how
OPP,
the questions.
yeah. So from matplot perspective, there would be one or two question only, okay, which would be mostly related to like functions or equations drawing, in which you have to identify the solution or something. Just that. These plotting things are just for your reference only. Okay, you don't need to draw them in the OPP.
Okay.
Simple plotting questions will come from matplotlib from the OPP perspective. Okay.
Matplotlib in Google Colab, no, not on the other editor.
Yes, on the Google Colab only.
So exam will be on Colab only?
Yes, Colab, and then there will be one portal in which you have to enter the answer, like GA, just like you have to enter the answer in GA. Solved on the Colab, and whatever all the answer will be like numeric format only. So solve in the Colab and enter that numerical value in the portal, Seek portal.
Okay. You'll be getting a mock before the real exam?
I have to check this with the team. I'm not sure.
So we got to know a little bit about types of questions and practice, no?
Yeah. I have to check with the team whether you will be sharing it or not. Okay.
Okay.
Is it mandatory to give this OPP?
It is not mandatory. It's up to you. If you have registered and paid the fee, then you can give it.
No, will it carry any grade
not the grade.
Any credit? Any credit? Additional
10
credits?
10 placement activity points you will get.
Okay, it's only for the placement, is it?
Credit, huh?
Yes.
It does not add to the credit.
No credit.
Okay.
This what is this placement? What is it? What is it you are talking about?
These are like for placement supports. Okay. I don't have more information on them. For them, you have to contact the support team or maybe join the support meet. Okay. You can get the information there.
Okay. Okay, thank you.
So in short, in the eigenvector matrix, the columns are representing the eigenvectors, and the highest eigenvector is the last one.
Yes.
The first PCA is the last one.
Yes, correct.
Okay.
So let's again load the MNIST dataset. Okay. So extract the data matrix. Okay. So the exploring part, like we have already done it. Okay. Like how many values are there? Okay. How many unique values are there? What will be the count of them? And how any image will look. This thing we have already done it. Let's now show the image of one.
You have to show one particular image, right? So
0. Okay. So this thing we've already did it. Now what we will do, we will create a subset of the data set. In place of working with all the labels, we will start with only two labels, 0 and 1. So that means we will only take the images of 0 and 1 with 2000 data points in each set. That means 2000 images of the 0 and 2000 images of the 1. Okay. So can you tell me how we can do this?
y equal to 0 and then colon 200.
Yeah, so x of
Y equal to 0 and then colon 200. 2000. 2000.
So let's put them in D1 and D2 is and there will be Y1 also because we want the labels also. Okay.
What are the labels actually, sir? What are the labels?
The labels are 0 and 1 here that we are using. Actual labels are like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
Okay.
If we are the labels are 0 and 1, then why we need to take that again?
No. Here we are creating a subset of the data set. Okay. In the original data set, we have labels from 0 to 9. And for the experiment purpose here, we are only taking with 0 and 1.
Yeah, that's what D1 is with y equal to 0.
Can you show Y1 and Y2? Can you show Y1 and Y2? I mean, just what is Y1 and what is Y2?
Y1 is like all the zeros. Y2 is like all the ones.
So why do we have to take these Y equal to 0 and then the 2000? Because they are mapped to that.
See, you will get to know why we are only dealing with here. See, we are basically trying to do here the binary classification setup, okay, instead of the multi-classification, okay. So that's why we are only starting with 2 labels only, okay.
Okay, got it.
So now we have to also make this a single data set, okay. So for that, we will be concatenating them. But before concatenating, let's reshape them into 2000 comma minus 1. D2 also D2 dot reshape 2000 comma minus 1. Okay. Now one thing also, if now if I want to plot the image, okay, map equal to gray, this will throw error, okay, because the size here is 784 comma, okay, while this show expect a matrix, okay, especially square matrix. So I have to reshape it again back to 28 cross 28 image to plot this, okay.
Yes, sir.
Now let's concatenate both the data sets, okay. So
sir,
yes,
what you just do? Can you please?
okay.
You reshaped it to 28 cross 28.
Yes, because here we have reshaped the data set into from 3-dimensional to 2-dimensional, right? And now if without reshaping, if you want to plot the image, this will throw the error because the MShow will expect a matrix, especially a square matrix, to plot the image. Okay, so that's why I have to again reshape it back to a 28 cross 28 grid matrix. Okay.
Why that 28 or 28? Why not it be 25 or 30?
See, the D1 of 0 has a shape of 784. So the size,
784.
okay, 784. So the size before the transformation and after the transformation should be same. So before reshaping and after reshaping, the number of elements should be 784 only. So you cannot reshape it to a 25, 30 matrix because 25, 30 will have 750 elements only, while it has 784. Okay.
How that 784 was picked up?
From here, because each image here in the MNIST dataset has a size of 784 only.
Oh.
Okay.
Sir, can it be reshaped to any multiple of 784?
Not any multiple of 784. Like you can reshape it to any size. Only thing you need to care about is it should have 784.
Any factor of 784.
Yes. But for the plotting purpose, it should be a square matrix only. Okay, if you want to plot. However, the reshaping, you can reshape a vector or matrix into whatever shape as long as you maintain the size of the elements. Okay.
Thank you, sir.
Here D1, when you are reshaping D1, D1 is actually having 2000 records, right? The first 2000 records of symbol 0.
Yes.
When we reshape D1 dot reshape in bracket 2000 minus 1.
Yes.
What happens?
So we have 2000 elements. Each element has the size of 28 cross 28. Okay. So now when you reshape, that 2000 element will remain same. The 28 cross 28, it will flatten them into 784 vectors or 784 size vector. Okay.
Okay. So minus 1 means how minus 1 get translated
so
into
minus 1 is
784?
if you just see, we know that total size is like 2000 comma 28 comma 28.
Yes.
Okay. So once you
Yes.
pass one factor, you can pass another factor as like minus 1. NumPy will automatically handle the size based on the total input size data. So in the input size here we have 2000 comma 28 comma 28. So that means minus 1 will collapse the 28 comma 28 into 784 vector.
So if in the MNest instead of 28 cross 28, if it is 64 cross 64,
then it will
then
just do the 64 times 64, whatever
okay,
that.
it will flatten to that. Okay,
Yes,
well, for that also we need to give minus 1 only.
yeah, you can also give minus 1 or the size, explicit size also. Both will work.
Okay. Not minus 2 or 0 or something
No.
like that.
No.
So one doubt I have, why y1 and y2 we have kept here, because y1 and y2 both are just arrays of 0 and 1 only. So why do we need to have y1 and y2?
That's the labels. We may need to use it for training.
They are different images of
To
2000.
make it like a tuple, right? To simulate.
See, these are the labels corresponding to these data points. That the data points that we had in the D1 and D2.
And these are different kind of images of corresponding to 1000 samples, right?
No, the Y1 and Y2 are the labels only.
Yes,
They're not.
and these labels are of images also.
These data points, okay, images of D1 and D2.
D1 and D2 are the images.
Yeah, and
Y1
and Y are their corresponding labels.
Okay.
Okay. Okay, so let's.
Each image has a label.
Yes. Let's start concatenating the data set into one now. So we'll use np.vstack. Okay, and we'll pass this D1 and D2, and I will do the transpose to make it a D cross N matrix. Okay, and we will perform on Y also, np.concat y1 comma y2.
There's a D2.
Oh, sorry, y1 comma y2. Oh, sorry, yeah.
Equal.
What is this base type?
Y equal to.
is equal to y equal to, sir.
Oh, thanks.
So y minus 2.
Thanks. Okay, so let's do the sanity check. Okay, 784 comma 4000. Okay, by dot shape, it is a 4000. Okay, good.
Can we concatenate images?
Yes, you can do the concat also. Okay,
What is the difference between concatenation and base type?
Just now we discussed that, right? The first thing that we discussed was this only, how you can, in different ways, you can do the stacking using vstack, concat, row stack, column stack, h stack, right? In the initial part.
Can you please give me the glimpse of that? I joined late.
See, vstack is just like the vertical stacking. So one on the top of another. So first we will have D1, and below that it will do the D2. Okay. Concat also, because here it's just a one dimensional array, so it will just put it behind it. Okay, y1 after y2. Okay, but if it would have been like two dimensional or more than one dimensional, then you have to provide the axis in what way you want to do the concatenation or stacking. Okay.
In VStack, access is not required. Fine.
Yes, access is not required. It will do the vertical stacking only.
Okay, thank you.
Okay. So now we have our data set ready. So we will do the PCA on this. Okay. So let's write one function to perform PCA on the given matrix X. Okay. What we need is the shape of the matrix X. Okay. Then first we need to center the matrix or center the data set. So for that we will do x equal to x minus x dot mean with x is equal to 1 with reshape to a d cross 1. Then is covariance matrix. Okay, so C equal to x transpose by n. Next is the eigenpair. Okay, so np dot len h dot ig of c. This will return in the form of tuple. So eigenval comma eigenval. Okay, eigenvalue comma eigenvector. Now what I will be doing here is flip. Okay, so np dot flip. Let me show. So if you have a vector 1, 2, 3 like this, if you perform the flip operation on it, okay, it will just reverse the order. Okay, and I'm reversing it because I want the top pieces, so I don't want to do this -1, -2 again and again, so I will just flip it. Okay. Like that. Okay. And for 2-dimensional array, like this, what will happen? You have to provide the axis. So first if I just show. This is your A. If you do flip on this with x is equal to 1, so it will flip based on this axis and you will get the final array like this. So this 3, 6 came in the first, this 2, 5 came in the second, which was already at the second, and 1, 4 came in the last.
This is what we want, right?
Yes, for the eigenvector. So that's what we will do for the eigenvector. Np dot flip of eigenvector with x is equal to
1.
That's all we need, and we will just return this eigen value and eigen vector. Okay. The center yeah. Okay, so now we will extract our PC and run this. So eigenvalue comma eigenvector on this PC on this data matrix X. Okay, and what I will be doing is we will extract the first 2 PC here. Okay, we will only work with the 2 PC, starting 2 PC. Okay, PC1 and PC2, and we can project our data set. So again, let's come back here. So now you have a, till now it is clear, right? From the code point of view. Okay, so this is your that PC matrix, okay, in which we have the PC1 and PC2, W1 and W2. Now you want to do the scalar projection here with respect to data matrix X. Okay, now this matrix here is of size what? what will be the size of this matrix?
Each W1 will be 784, right?
Yes.
W1 will be 784. So 784 into 2.
Yeah, correct. Okay. So this is of 784, 2. Now, I want to use only first two pieces, and based on that, I want to project it. Okay. So we only want to do the scalar projection. Okay. That is basically just for our data metric x, which is like x1, x2, okay. We got and xn. Okay. So here we had like 7, how many? 6,000, 4,000. Okay. This matrix, we want to transform it into new matrix of x dash, okay, which will have only the scalar projection, and how it will look is basically
X
x1 transpose w1, okay, and x1 transpose w2, okay. That's how the coordinates will look for the projected pieces for one vector, okay. And this we want to do it for all the data points. So xn transpose w1 and xn transpose w2. Anybody has any doubt? Okay, this is just the scalar projection that we want to do for each of the data points using PC1 and PC2. Till now, is it clear?
Yes, sir.
Okay. So in the form of matrix, how we can write this?
XW, X transpose W.
Okay, X transpose W. So 4,000, 784, 784. Yes, that is correct. But I want this shape. I want the shape to be in this form. Like, you mean here? Again, d cross n. So 2, 4,000.
Yes, 2 comma 4,000. 2 into 4,000.
Okay.
2 into 4.
So how we can write this as, see, for a dot product, whether you do x1 transpose w1 or w1 transpose x1, it will be same, right?
Yes.
Okay. So I can basically do this. Right. And this is w. This is 1. Okay. So this is basically, if you think here, same as w transpose x, right? Because how your w vector here, when you do the transpose, they will go in the row wise. Okay. So this would be your w1. This would be your w2 in the row format. So it's basically like w1 transpose. Okay. And then you have this data matrix in which your vectors are column wise.
So it will be 2 into 784. This W transpose will be 2 into 784.
Yes, correct.
And this will be this will be 2 into, so how can it be multiply? This will be 784 into 2000.
See, this will be of shape 2 into 784, right?
And this will be
this is of
784 into 2000.
4,000.
4,000, yes.
Yeah. So the multiplication will be possible, right? And the resultant
Yes,
would be
yes.
2 into 4,000. That is this
Yes,
matrix.
yes, yes.
Okay.
Can't
So
we
this
do
is,
X transpose W? That also is possible. Na?
that is also, yeah, that is also possible. But then if you want to follow the convention, you have to again do the transpose. So it's basically the transpose of that, right? If you think of it like the transpose of X transpose W. W transpose X, right?
Yes, yes.
So that's all. Just to follow the convention, I'm going in the way of D cross N. Otherwise, you can do the X transpose W also. That will give you the same result. So
Yes.
any doubt here? If it is clear, then as we have obtained the W, so our new X would be W transpose X. So, okay. Now, time for plotting this. Okay. So, PLT dot scatter for new X I have to take. Now, if you see, we are coming into basically 2 dimension. From 784 dimension, we have come to 2 dimension only.
But sir, we are applying this W to the same X, same training data set only. We should apply it to the test one, right?
Yeah, no. We should apply into the both. Actually, what you should do is whenever you are doing any kind of transformation or any kind of pre-processing steps, these all include the pre-processing step. You should apply them on the both training and test. Okay. And especially whatever the parameters that are learned to apply those transformation, only using those parameters you should apply on the test also. Maybe you will learn this more in MLT, how this pre-processing works actually. Okay. Okay, so now if I show this, what went wrong? Shape of 4,000. Oh, okay. I did not do this, so that's why I have to run it before.
Before it was taking only one vector, right? Now it
Yes,
is taking
two
two
vectors.
vectors. Okay.
Okay. So this is how the plot will look. But now, if you see, there were 2 classes initially, right? One was 0, other was 1. Okay. So let's try to plot it in such a way that we can distinguish both the class. Okay. So for that, what I will do, we will create a numpy array of colors. Okay. So we will create a numpy array of colors. Give me 1 minute, please. Yeah, sorry for that. So what we will doing, we will create a color array. The first color we will put it red, and for the second one we will put it green. Okay. Then here there's one parameter C in which you can pass the colors of Y. So if I show you how the output of colors of Y will look, for that I have to put them different. Remember, Y has 2 things, 0 and 1. So wherever Y has 0, it has taken the 0 index color, that is red. And wherever Y has 1, it has taken the 1 index color, that was green. Okay. So this colors of Y will now become an array of size Y, in which wherever it was 0, it will have the color red, and wherever it was 1, it will have the color of green. Okay. And that color array, we have passed it as the parameter of C. And now if you run this entire thing, you will get them in the colors. Okay.
So
Yes.
these colors, I did not understand what you did here.
Just to distinguish between 2 classes, okay, 0 and 1, I created this color array, okay, of red and green. So red is at index 0 and green is at index 1, right? And I am passing this array of Y into this color. So using advanced indexing, what NumPy will do, wherever the index was 0, it will give the color of red, or that means the colors of Y. The output of this would be wherever it was 0, it will be replaced with red, and wherever the index was 1, it will be replaced with green. If you see, okay. The original Y was something like this. So initially it was all 0, 0. So 0 will become red and 1 will become green.
Okay.
Okay. And that colored array we have passed as the parameter for C.
Okay.
These are labels being red and green, right?
Yes. So here I should change to different color. Black. Yeah.
So
So
new
this,
x 0 is 2 into 4000, right?
yes, each data point is of 2 dimension. So that's what we have plotted. Zero color here, oh sorry, the red color here represents for those data point which has a label of 0, and green one depends or shows the color of or the label of 1. Okay. So these are all the data point which has label 1. These are all the data point which has label 0. Okay. I will do one more thing here, alpha. That's basically controls the opacity. Okay. So it's just to control the opacity. Now, wherever it is more dark, we can say that like more data points are centered around there. Okay. Now, you can use now this data set to perform any downstream tasks for any binary classification problem, like for using any linearly classifier, you can draw one line like this to distinguish between two classes.
For me,
Okay.
everything looks green. I do not put red.
Have you did these steps correctly? Your y, check your y whether they are 1 or not, or whether they are 0 or not.
Maybe you are not concatenated.
Yes, those might also be the problem. Okay. So anyway, the collab, the solved collab will be shared after the session, so you can look from there also. Okay.
Sir, instead of 0 and 1, if we choose something like 4 and 7,
Yes,
still
so
we will be getting the same thing like what we are seeing now, or it would be of the shape of 4 and 7.
not the shape of 4 and 7. The data set position might be different. So let's try it out. So 4 and 7. 4 and 7. Okay. But now we have to do the color thing also here. Okay, we have to do the replacement of 4 with the 0 and 7 with the 1. Let's try it out how much we can go without changing anything. So till here, if we run, okay, this will because 4 is out of index bound. So what we have to do here is basically replace 4 with 0 and 7 with. So I guess yes.
So you can add some more, no sir, in that colors list.
Yes,
Add
you
some
can
more
add
colors,
some more.
yeah.
Oh yeah, that
Maybe
also we can
here.
do. So what we can do here is we can leave some of them blank. 0, 1, 2, 3. 0, 1, 2, 3. 4 is at red. Then 5 is blank.
Comma, you forgot, sir.
Oh yeah, thanks. So this is at 0 index, 1 index, 2, 3, 4, 5, 6, 7. So now this should work. Okay. Something. Index 4 is the out of bound for x is 0 with size 2. Oh, here the same color array is getting used. Now you can see they are different, how they are appearing here. Okay.
So what is the significance of this, what we are seeing, sir, here?
So this is basically the PCS and unsupervised learning problem, right? So we can use this as a pre-processing step to reduce the dimensionality. So from 784 features, we have bring down to 2 features only. Okay. Now for the visualization purpose, now you can see how easily you can distinguish between two classes, and you can use this data to, for any model training later on. Okay. So if you will work with 784 dimension, it will be more computationally heavy than with just 2 dimension. Of course, you have to also make sure that you do not lose much information. Okay. Otherwise, there might be bias in the training. Okay.
So can we plot a individual x, new x0 or new x1 and reshape it and see what is actually the image that we get?
So now you are in 2 dimension. So this
Okay.
reshaping will, because you have only 2 features. So now
Okay,
you will not be
okay.
able to reshape that. Okay.
Okay.
Why is the view different when you are using multiple colors? It's not the view different. We have changed the data point itself. Initially, we were working with 0 and 1. Now we are working with 4 and 7. So that's why this changes happen. Okay.
We can recreate that 4 or 7 using these principal components, correct?
For that, you have to do the full projection. Okay. And that way you will be able to do it.
Can you show it in short? How we can get it?
It's just that you have to multiply it again with the weight vector. Okay, how the simple scalar projection work? It's just x transpose w. Okay. For the full projection, it is x transpose w multiplied with the w. Right. The actual projection, if you want to project a vector u on v, is basically u transpose v divided by v transpose v. If v is a unit vector, it's just u transpose v times v.
So these are just the scalar
Yeah.
projections. These are
Yes.
just what we have plotted are just the scalar projections.
Yes, correct. If you again
Okay.
multiply it with w, then you will be able to recreate the images with 2 pieces.
Right.
Okay. Any more doubt?
W is 2 by 784, correct?
Yes, correct. One. Yeah, so anybody has any more doubt? Okay,
We take
so
more principal components, we get a better separation, correct, sir?
yes. But then you will not be able to plot it. That's why we only stick to 2 so that we can plot it. Okay. So if no more doubts, then we will move on to k-means algorithm now.
So these solved collabs you'll be sharing.
Yes. It will be shared in the folder.
Okay.
So closing the other collapse now. Okay. I hope there's no more doubt. Okay. I'm closing those collapse now. So let's start with k-means. So again, for the k-means, we will start with a toy data set. Okay. 4 and 7 is index instead of 0 and 1. In what place you are talking about the index position? It's just the color mapping that we have to provide. We want the color of label 4 to be red and label 7 to be green. So that's why the other places we put them as comma, just or simple blank string. Okay, so that no color will be given to them, as we have the labels as 4 and 7. And another method to do this is you have to replace the 4 with 0 and 7 with 1. Okay, that's another method in which you can do this. And just again simply use the same color array, red and green only. So let's start with rng np.random dot default underscore rng with seed value to be again 42. Okay, now here we will be creating with 3 means. Okay, because we will start with k means for 3 clusters. Okay, and means would be minus 3 comma 3, 3 comma minus 3, and 3 comma 3. Okay, so these are the initial means that we are starting with in which you are creating the data set. Okay. Covariance, let's just take the identity only. So we will create with 60 data points and 20 data point each cluster. Okay, so we have 3 clusters, so 60 data points. So RNG dot multivariate normal, in which, okay, so we have to do this and now how we want to create the data set is the first 20 data point should take the first mean. For the next one, it should take this mean, and for the next one, it should take this mean. Okay, so that's how we want to go with, right? So for I in range of P, okay, I want to create this multivariate normal of mu's of I and the covariance matrix. Okay, and the size is, yes. Please, any doubt if you have?
So what is it? N double divide by 3?
It's the integer division.
Okay.
Okay. So here we will be using the list comprehension method. Okay, for the for loop, and what this will return is 3 arrays. Okay, and in one array we will have 20 data point. In the next array we will have 20 data point, and in the next one also we will have 20 data points. Okay, the first one will have the mean this one, the second one will have mean this one, and the third one will have this one mean. Okay, now we want to stack them, okay, vertically. So you can either use vstack. I will be here using concat with axis equal to 0. Previously we used vstack, now we will use concat for the stacking with axis equal to 0, and we will do the transpose, so that we will get the size in the form of d cross n and store them in the matrix X. So if we check the size,
Axis equal to 0 is vertical stack only, right?
yes, vertical stacking. So as we have 3 array, we just stack them one on the top of another. So like one this, then this, then this. Okay. So is the data creation part clear? Okay. So let's try to visualize it. plt.scatter. So this is how we can see that there are 3 well separated clusters. Okay. So let's create one function for the k-means. Okay. So df k means, okay, which will expect the metric X, and we'll go with 3 clusters. Okay. Now k-means has 2 steps. Okay. One is like initialization. You initialize the or how the assignment will happen. Okay. And then you will update your centroid. So you will keep doing these 2 steps again and again. Okay. So step 1 is assignment, and the step 2 is recalculating cluster centroid. Okay. So remember in the lecture, for the assignment step, we use z variable. Okay, z. So now what we will be doing is we will looping through all the data points for I in range n. Okay. We will calculate the distance of the mu's. Okay. So first we have to initialize the mean also to something. So okay, to initialize the means, initial we will start with some centroid. What we will be using is rng.choice. Okay. Now, if I like pass 1, 2, 3, 4, okay, and I call it like 2, and say it's equal to false. So what it does do is it will extract 2 elements from this 1, 2, 3, 4, okay, and replace equal to false. That means the extracted element will not repeat. Okay. So 2, 1, 4, 2 from this array. Okay. And if I do not set this replace equal to false here, then the element might repeat like this 1, 1. Okay. So what we want from the data points that we had, we randomly want to choose any 3 data point for the initial cluster centroid. Okay. So for that we will be using this rng.choice. Okay. And first we want to give some indices to it. So we have n data points. Okay. So out of those n data points, choose the k data points with replace equal to false, because we don't want to repeat any data point for the mean. And this will give us the indices of the selected data point for the cluster mean. Okay. And the muse would be just the selected data points. So is this initialization part clear, first of all?
So we have taken just one mean here.
Not
How
one
many
mean.
means? How many means we have?
See, out of n, we are taking the k means. So k is 3. So just like here, out of these 4 elements, we are selecting the 2 elements only. So just that's why it was giving us 2. Okay. So this will return the indices, and those indices we are passing to this X matrix to select the mean. Okay.
But all these are two-dimensional data points, right? So we have
Yes,
to
yes.
choose. So k is equal to 3. I'm not getting this.
See, np.arrange, what it will give? An array of from 0 to n. Okay. So 0, 1, 2, 3,
Yes,
4 like that,
0.
right?
Yes, yes.
Okay. So maybe if I show it like this. So try np.arrange of n. Out of n, let's choose 3, k equal to 3 here, with replace is equal to false. Okay. So this will give us any randomly chosen 3 indices like this. Okay.
Right, right.
Let's store them as indices. Now if you pass them to this, it will return the data point at those indices value. Okay.
Okay.
So
Okay.
these data points we are choosing as the initial cluster mean.
Just selecting all the columns, right?
Yes.
The
And
data.
because our data points are in the column, so
Columns.
that's why. Okay, so we have initialized the mean. Now we will loop through all the data points. Okay. And we will basically be calculating.
I'm not getting this.
What part?
The first part I'm clear. After passing it to the indices, I'm not getting it.
So see, we have got some indices, right?
Yes.
Okay.
Yeah, up to this I'm clear.
Okay. Let's say this 16, 4, and 9. Okay. So we are passing this list to this data metric X to extract those data points at those indices. We can also pass a list also, right? For a list of indices. This is the advanced indexing that we did yesterday. That if you want to extract the elements at certain indices, you can pass the list of indices also for slicing in the NumPy array.
So X colon index will be 2 by 3 matrix, right? 2 by 3
Yes,
matrix.
correct.
It
This
will
will
be a
be
2
2
by
by
3.
matrix. Correct.
Yes.
Okay. And it will have the data point which is at the 16th position, 4th position, and the 29th position. Okay.
Okay.
And those
So
are
you are doing it randomly. You are choosing,
Hmm.
and then you are taking it.
We are randomly choosing some data point, 3 data point for the initial cluster mean, because initially we want some, right?
Okay, some randomness to pick the mean.
Then in the
So-
next step is yes. Yes.
Sir, actually, in for I in range n is not defined anywhere.
N is defined initially here while creating the data set.
Okay, sir.
Sir, indices are rows or columns?
Indices are not rows and column. These are basically the index that we are choosing for the data point. So this we are passing as the column number here because our data points are at the columns. Okay.
Okay.
Yeah. So the first step, that is the assignment. So what we will be doing here is we will calculate the distance of each data point to each of these means, the initial means that we have decided here. Okay. And based on whichever has the minimum distance, we will assign the that data point to that cluster, right? So muse minus this will go with np.lin-elch.norm. Okay. Now here you have to provide the axis. So what will be the axis here? Can anybody guess it?
1.
No, it could be 0. Now I will tell why. So let's say okay. So think like this is your output of mu minus this vector. Okay. Think of it like this. This is your output of this. You have subtracted the columns and this is the now output. So if you want to calculate the distance, how you will do, right? You will do the summation of these two, right? And 2 and 5, the square of 3 and square of 6, like that, right?
Yes.
Because, so like if you have the data point x6, x, m equal to some 1 comma 2, okay? And your initial means, well, like is only, okay? So now you will subtract this 1, 2 from each of these data points, okay? Remember 1 comma 4 is a mean, 2 comma 5 is second mean, 3 comma 6 is the second mean. So if you do the subtraction here, okay, what you will get is 1 minus 1 0, 4 minus 2 minus 2, 2 minus 1 1, 5 minus 2, 2 minus 5 minus 3, 1 minus 3 minus 2, and 2 minus 6 minus 4. Okay, so then you have to do the summation or squared summation along top to bottom operation, correct? So that's why the axis value would be 0 here. Any doubt?
Yes, sir. The last part you just did.
So see,
And
this was the output of mu minus the data point. Till here it is clear?
Yes.
yes, sir.
So see, if I go with like 1 by 1, 1 by 4, 1 comma 4 was your first mean. Okay. So 1 comma 4 was your first mean. This was your data point. If you are going to calculate the distance between these two, how you are going to calculate? 1 minus 1 whole square plus 2 minus 4 whole square, right? 1 minus 1 is 0, 2 minus 4 is minus 2. And if you do the squared summation, you will do summation along this way, right? Top to bottom. Okay. So that's why here it was axis 0. One more thing we have to check is that is this. Here we have to reshape it,
Yes, sir.
right? Because it was a column vector,
Yes, D1, D1.
d
Yes.
comma 1. Because it was a column vector. Remember when we studied broadcasting yesterday, for the row vector, when we had, it was not a problem, but when you are subtracting column wise, you have to reshape it. Okay. So this is your distances. What we actually need is the
Minimum.
which one minimum distance, not the minimum distance we care about. We care about which mean or which cluster has that minimum distance, right? From which cluster it has minimum distance. So basically, argument of that. So np dot argmin.
Argmin, yes.
Okay. So this will give us the index position of 0, 1, 2 only, because the distances array will be like this. It 2 cross 3 only. Okay. And among that 0, 1, 2, okay, it will give us as the output. And that we will assign as here. So Z here is the indicator variable that the data point I has this cluster. So Z is the indicator variable. So we have to initialize the Z also. Np dot zeros of n. Let's start with zeros of n. Okay. So this is the initialization of Z. Till this first part, anybody has any doubt?
No, sir.
Okay. Step 2 is simple. So that is the recalculation of the cluster centroid. So now what we will do for I in, okay, just to avoid confusion, let's go with J of K. Okay, so we have 3 clusters. We will select all the data point in which the cluster label is J. So J will run from 0, 1, 2. So wherever the cluster label, cluster indicator is same as this is J. Okay, we are selecting all those data points, and now we have to take the mean of those data points, right? So dot mean, and what will be the axis?
1.
1, right? Because our data points are column wise. So you want to take the mean. So left to right operation, axis value would be 1. Okay. And we have to replace the previous mean also, right? So this will be a new mean. Mu's of J will be replaced this new calculated mean. Okay. Anybody has any doubt in the second step?
No, sir.
Okay. Now one corner case here, that is the NumPy might give a warning if this array is empty. That means there's no data point for which the label was is J, okay, or the cluster was K. Okay. So if you take the mean of the empty array, then NumPy gives a warning. Okay. So to avoid that, we will use np.ne of Z equal to Z. So what does it mean? Like if you have a Boolean array, so np.ne will return true if any of the element here is true. Okay. If only if all the elements are false, then only it will return false. Okay. So if np.n is Z equal to Z, that means there's at least one data point for which the cluster indicator is this J. So J will run from 0, 1, 2. So the cluster is among which of them. Then only we are calculating the mean and updating it. Okay.
Z equal to J is giving a array of true and false, right?
Yes. Array of true and false. And it will be basically those data point for which the cluster indicator was J. So J, whatever value it will take. If 0, then whichever the data point are assigned to the cluster 0. Okay. So like that. Okay. So till now, anybody has any doubt? Now we have to run both the step 1 and step 2 until when? Until your cluster assignment does not change, right? So
Yes,
until
sir.
your cluster assignment does not change, so while while something will not happen here, we will do these two steps. So now something is what we have to also create one more variable here, z previous. So what was the previous cluster assignment, and this z would be the new cluster assignment. Okay, and while these two are not equal, okay, so remember we studied this np.array underscore equal. So until the z and the z previous are not equal, okay, until these two assignments are not equal, we will run these two steps. Okay, and initially we have to start in such a way that both of them are not equal. So that's why one we are initializing with zeros, other we are initializing it with 1. Now until both of them are not equal, we will run these two steps, that is the assignment and recalculation step. But one more thing here, that
Z previous we have to give as the
yes, here we have to like capture
Z
the
equal to
previous,
Z.
okay, but we cannot just write it like this, z previous equal to z, because this would be like a soft copy of it, not the hard copy. Okay, so basically both of them are pointing to the same memory location here. Okay, but to make a deep copy, there's something copy. Yeah.
But these are arrays, na? In arrays also that issue comes, hard
Yes,
copy and
yes. So if I show np.array, if I do a equal to b, sorry, b equal to a. Okay, now if I change something first, b is a, this is true. Okay, if I do like b of 1 is 100, and now if I print both a and b, okay, the value is changed in both of them.
okay.
So for that you have to do this hard copy. In this way, it won't. Okay, and if you print this is b is a, then this will also return false. And here you can see in the a value it is not changing, but in b array it is changed, because here we have changed it. So this is to create a deep copy of it. So that's why we are creating it here. That's all. Anybody has any doubt? Now we will just return the cluster assignment and the muse, the final cluster centroid. So that's all. Let's visualize it. Okay. plt.scatter. Now, in what way we have to visualize? Okay. Right from
color.
Colored, yes. So now we will basically color them. Okay. Here. What is there? Could not broadcast of shape. Oh. 2 into of shape 3. Oh, okay. My bad. So because our muse are arranged column wise, right? So that's why we have to replace the column here. Okay, so colon, comma. Now this should work. Yes. So let's look at how we are cluster assignments. So initial all are 2, then all are 1, and then all are 0. And we expect it to be, because that's how we are stacking all the data points, right? All the data points that belong to one cluster were together, and the next one were together, and the next one were together, right? So that's why the cluster assignment is also like this. So that means our function is working fine. Now we want to just not only just plot the simple scatter plot, we want to plot them based on this cluster indicator. Okay, so just like we previously we created this colors array, right? So red, green, and purple, maybe yellow. Okay. So now there would be one problem here. That is, if you see how your cluster indicator, they are like float type, right? They are 2.1 point. Okay. So what is the problem here? That you cannot pass the floating data point as the indices here. You can only pass the integer values. Okay. So we have to convert this array, which is currently of float type, okay, to integer data type. Okay. And now how we can check the data type? Using d type. You can see that it is of type float. If you want to convert it into an integer, then what you can do is 0 f type, right, int. So now these are all integer data type. Okay, and now you can use them for the indices.
As type indicates what?
To change the data type, we use the as type function. So this is to what data type you want to change it. Okay, colors of z dot as type, and we'll pass it in. So now you can see, okay, yellow was not a good idea. So maybe okay. So this is how your final cluster assignments will look. Okay. So anybody has any doubt?
Can you plot cluster means?
Sorry.
Cluster means, can we plot them?
Yes, cluster means also you can plot them. So let's plot the cluster means also. So, get
News.
okay, news 0 and news of 1. Let's give them color. We are using the colors here. Let's keep this green, and here we can get the color black. Okay, so here is your cluster mean. Okay.
But mu's are in is 2 cross 2 into 3, right?
Its mu's are in 2 cross 3 matrix, in which
Yes.
column wise they are mean, right?
Column is the mean, right? The
Yes.
column is the mean.
Correct.
So x-axis on 0 and y-axis. Okay, right.
Okay. The same way we are plotting the data points, same way we are plotting the mean also.
Okay.
Okay. Any more doubt?
So we started with randomly selected means, and we came down to this. What do you say?
The final assignment.
Final assignment.
Okay. Now let's check also how they are close. So see, these are the means, okay, that we got after doing converging the k means. But if you see the starting from the means from which we started with this -3, 3, 3, -3, and 3, 3, from which we created the data set. But the mean that we got in the end is this. It is close to what it should be, but not exactly the same. Okay. So, okay. Yeah. So the rest part is basically about that only, like about copying it, okay, and the data type changing. So that's all for the k-means. Anybody has any more doubt in the k-means?
What was the last part, sir? You said
these are like same thing. The copy and how you can point to the same object and the F
Okay,
type.
okay. Copy because of that. What do you say? That issue, that
Yes.
hard copy
Hard
and soft copy.
Okay.
So in the OPP, we may be expecting questions like the random generation part will be coming as a question itself, and we
Yes.
need to find the means, right?
Yeah. So see, you never have to generate any data set. The data set generation part will be given to you already as a code cell, and do not change the code cell which contains the data generation part. Okay. What your task might be from k-means is like perform the k-means on the given data set, and then maybe like find that you know from which cluster the test data point belongs to. Okay. What is the final mean after convergence, like that? Okay. Those might be your questions. Yes, Andrew.
Sir, again, same thing as last time, sir. It would be really helpful if you could share the previous year's questions, sir, because you were explaining also, you're saying what to do, what not to do. But if we have the previous year questions, we can actually work through it.
Yeah. So see, today was Sunday, so I was not able to talk. Okay. Tomorrow I will talk with the instructor, okay, and see what we can provide.
Yes, sir. Thank you.
Any more doubt?
Sir, when is the OPP?
11th May.
11th May. Okay.
How many questions and how much time we'll get for that?
2 hour, and number of questions are like I guess 18 or 19. Okay, it will be of 50 marks. So 50 marks OPP in which you have to score at least 40%. So like 20 marks out of 50 to get the certificate.
Sir, when will be the timings finalized?
The timing is, we have to check maybe after the workshop ends. Okay, after that we will might finalize.
Yeah, please take a poll actually.
Yeah, sure.
So today's content is over, right?
Yeah, technically we want to do one more on the linear regression, but yeah, time is over. Okay, so we'll not be able to cover it entirely. So, okay,
Can
1
we
minute.
start tomorrow early?
Yeah, 1 minute.
Excuse me, sir.
Yes.
Sir, I'm getting an error as numpy has no attribute concat. Like it was just working fine.
NumPy has no attribute concat.
Yes, sir.
Can you check the spelling?
So it is written as concat.
Yeah.
np.concat.
Can you share your screen once?
Sure, sir.
So others can leave, right?
Yes.
Thank you,
We
sir.
are done with the today part of.
Thank you, sir. Thank you very much.
Tomorrow is the last day of the workshop, or there'll be more days?
Technically today's sorry, tomorrow is last day, but if everything is not able to cover, then we can extend to one more day.
I have a request to you. Can you solve any one of the PYQ, like how we can approach?
I have to ask to instructor about this. Okay, if we arrange one more session for that, then we
Yeah,
will be calling.
please, if you can do that, it would be better.
Yeah, sure. Yes, Andrew.
Yeah, that same elaborating on that. Just if you could just send us the folder, it's more than enough. So, like I feel, yes, thank you. Like at least because you will have the set of at least past 3 terms, I'm sure you will have, you will use that only as a blueprint to make the new question. At least if we could use that, we could actually help us clear it and give us more practice than just working through the code cells and just copying. Maybe if we actually attempt it ourselves, then we'll know where we stand and will actually help us clear. The clearance rate also will be more. But thank you.
Okay, I will talk it. Okay.
Sir?
Yes.
Will the Google Collabs of all the sessions with complete codes can be sent?
Yes, they are already uploaded in the shared folder, right? In the G space, I shared one folder with MLT Workshop. That folder it is uploaded.
Like where can I get it?
In the G space, it is there.
This space I'm not getting.
if you are not added to the G space, you can ping Vishal sir. Okay. His email ID is vishal@study.iitm.ac.in.
Okay.
Yeah.
So
Done.
here's the error.
Yes. Why it's giving this error? np.concat. Telling us okay.
Thank you.
Welcome.
Sir, tomorrow same time, no, sir?
Yes,
8
same
to-
timing. Yeah,
Thank you,
8
sir.
to 10. RNG.multimedia user file range. Yeah. Okay. Can you reload the NumPy again once?
Sure, sir.
Run this file. Run it.
Some errors.
Right. Can you try with concatenate full form? Concatenate. Yeah. So maybe
Yes.
I'm not sure why it should be, but I think there might be some older version in your Colab system. Okay. So
Okay.
that's why. Okay. That's for
I see. Thank you, sir.
help.
As of now, the shared folder has only 1 and 2, right? 1 and
Yes.
2 days.
Yes. Day 1 and day 2. The day 3 I will upload it after the session, or maybe I can upload it